Hi everyone, welcome to the 8th session of the Introduction to Big Data series. In this session, we will understand more about Apache Hadoop. If you haven't subscribed to my channel yet, please click the bell icon below and subscribe so that you get notified when I upload new videos. In the previous session, we understood what big data analytics is and the limitations that were existing at the time when the need for big data analytics came up. Big data has structured, unstructured, and semi-structured data. For structured data, we can use databases for storage, but this can't be done for unstructured and semi-structured data. Even then, since there is a huge volume of data, we will require a lot of DB racks, which will make the infrastructure very costly. Also, to do the analytics, though for structured data we have SQL, which is a structured query language, we can't use it for unstructured and semi-structured data. To solve the problems of storage as well as for analytics, Hadoop was developed. Before we understand what Hadoop is, let's understand what led to the development of the technology behind Hadoop. Over the years, there have been tremendous improvements in the CPU speeds. Back in the 1990s, it was just 44 millions of instructions per second at 40 MHz that were executed. But now, it is almost 2.3 million MIPS at the rate of 4.35 GHz. Similarly, the random access memory size, the RAM size, which was just 640 KB, has grown to 32 GB these days. Same is the case with disk capacity as well. Right from just 20 MB, it has grown to 15 TB now. Please be noted that the values that I have put here are based on commonly available standards in the market. Now, being said all that, the most important thing to be taken into consideration is the disk latency, that is the speed of reads and writes from a disk. This hasn't improved much over the years. Currently, the best available rate is from 80 to 160 MBs per second. Let's try to understand what this means. If we take 160 MB per second as the speed of reading from a disk, then to read 1 TB of data from one single disk, it will take around 1.73 hours. 1 TB in the context of big data is not at all huge, but taking almost 2 hours to just read that data, this is something not acceptable. But if we split that 1 TB of data into 10 disks, then read that data from those 10 disks in parallel, it will take only 10 minutes. And on similar line, if we take 100 disks, it will just take 1 minute. And if we have 1000 disks, just 6 seconds. The key takeaway here is the more distribution of data combined with more parallel processing, the lesser time it takes. Something was existing already which worked on the same methodology, grid computing, where there was distributed workloads, parallel processing spread across with parallel databases. But there were a lot of challenges as well, like the difficulty in managing the applications that were running on the grid, limitations in scaling up, difficulties in maintaining the concurrency of processes, absence of fault tolerance, limitations in security, etc. Apache Hadoop is the answer to overcoming all these challenges and replicating what grid computing is doing. Apache Hadoop is an open source framework which has data distribution as well as parallel processing. It is fault tolerant, meaning the Hadoop system can continue operating properly even in the event of failure of some of its components. Along with this, Hadoop is also made up of commodity hardware, meaning the disks and nodes that comprise the Hadoop cluster is relatively inexpensive, widely available, and interchangeable. Since redundant array of independent or inexpensive disks or RAID data storage technology is not cluster compatible, LVM or logical volume manager obscures the real disks, and SSDs or solid state drives are unfit for streaming data and are very costly. For Hadoop, the JBOD or just a bunch of disks, which is a collection of hard disks that have not been configured but acts as an equivalent to RAID, is used. Apache Hadoop consists of 4 subprojects, which are HDFS, Hadoop Distributed File Systems, MapReduce, Yarn, yet another resource negotiator, and Hadoop Common. Among these, Hadoop Common refers to the collection of common utilities and libraries that support other Hadoop modules. It means that to integrate any new technology that is developed with Hadoop, the API that can be used is the Hadoop Common. Some of the other Hadoop projects that are integrated using the Hadoop common are HBase, Zookeeper, etc. That concludes this session. Thank you for watching. If you liked this video, don't forget to click the like button, share your suggestions as comments, as well as share the video and subscribe to my channel.